How's it going, nerds? Welcome back. The Immortal Nerd here, your immortal instructor slash tutor slash professor, whatever you want to call me. Last video, we did the first part of the chapter 1 section for the pre-calculus calculus of the 4th edition book for pre-calculus functions and graph from the Arthur Dugopolsky. It was the finding all the real and imaginary solutions of an equation. We did 3 problems. We did 3 problems of those. I know I said in the beginning before we started we was going to do 4, but 3 was enough for a good amount of time for a video. I didn't want to go too long because some of our attention spans aren't that good, or we just we want to look at certain pieces and not the whole video for a particular problem, because we may be good on some things and maybe not on other things. So yeah, so in the last video I did say for this one we'll be talking about graphs, knowing how to graph certain functions in the XY coordinate. So with the first problem, as you can see here, we're starting with a standard slope-intercept form equation and learning how to graph it on the XY coordinate system. So as you can see before me here, I have the equation y equals negative 2/3 x plus 4, and my sample graph sheet next to me. So I'm not going to put any numbers on them. Just know that the middle is the origin, which is always the point 0, 0. And for this particular problem, each line is going to be an increment of 1. That's going to be enough for this equation here. So what I said earlier about this linear equation here is that it is in its slope intercept form. So slope intercept form, that is y equals mx plus b. The m represents the slope, the b represents the y value of your y-intercept point, so in the form of 0b, and y and x, those are your any other values that you get when you're plugging in any other value besides 0 for x or 0 for y. And the reason for that is because, again, with the b portion, the reason why it is the y value for your y-intercept is because, take a look at the x value. The x value is always 0 for your y-intercept, and the y value is always 0 for your x-intercept. So I want to write that down as well. And you will notice whenever you graph any type of linear equation, in this case, the intercepts will intersect or intercept the x-axis or y-axis. That is why they are called the x and y intercept. So here we're most likely, well, we are going to see those x and y intercepts, and we can label those when I finish them. But first things first, graphing it. So in order to graph a linear equation, and we already have it in slope-intercept form, what we're going to do first is find out what is the y-intercept. So in order to find out the y-intercept, we're going to use what the y-intercept looks like in ordered pair form, which is the 0, b. So we know what the x value should be for the y-intercept, 0. So we're going to use that information to plug into this linear equation of y equals negative 2/3 x plus 4. So in doing so, we get, let me move this up, y equals negative 2/3, plug in the 0 for the x, plus 4, and evaluate. So negative 2/3 multiplied by 0 is 0, plus 4, that gives us 4. So the y value when x is 0 is 4. So that tells us the y-intercept is 0, 4. So I found my first point that will go on this graph. Good. And that is all the evaluation we would have to do. So I'm going to plot that point on my graph here. So I'm going to do that in blue. So 0, 4. So the center is always the point 0, 0. And I'm going to graph 0, 4. So the 0, again, that represents the x value. So that tells me, or the x tells me that I need to move either left or right, depending on what that x value is. Now, since that x value is 0, that tells me I don't need to move left or right. So it's saying pretty much 0 units away from the center. So I don't move from the center. So now the 4 part. The 4 again represents the y. So that y value tells you to move either up or down from the position that you're at. So since I'm still at the center or the origin of my graph, I'm going to move 4 units upward because it is a positive 4. If it was a negative 4, then, we will move it down 4 units. So up 4 units from the center. 1, 2, 3, 4. That's here. So this is my point 0, 4, which is also the y-intercept. So now, to complete what this line should look like, I'm going to use the slope. So the slope, move it back down a little bit. The slope is the m portion of my slope-intercept form. That is the coefficient of the x. So in this case, that will be the negative 2/3. So this is good. We have our slope, or you may be familiar with, it's called the rise over run. We know what those pieces are, so that will tell us where to move to locate our different points. So now you see that it has a negative in front of the 2/3. So you may be wondering, where would the negative be placed? Would it be placed with the 2, or would it be placed with the 3? It does not matter where it will go. It's all up to you. It's all about preference. So what I'm going to do is place the negative with the 2. So that will tell me my rise, quote unquote, rise is a negative 2 and my run is a 3. So from the point that I am at now, which is the y-intercept, I'm going to use that information to get my other points. So the negative 2 being the rise, or in this case, it would be a fall since it's a negative 2. That tells me I'm going to move from my position that I am at now down 2 units. 1, 2. And then my run, which is a positive 3, that tells me I am going to move it to the right 3 units. 1, 2, 3. Here. And then I will continue on with this. So from the spot that I am at now, I'm going to go down 2 units. 1, 2. And to the right 3. 1, 2, 3. And I'm going to do it one more time. Down 2, 1, 2. And to the right 3. 1, 2, 3. Good. And here is my line. Okay, so simple. That's it. That's all you do. So notice the third point that I made here, or third plot, that one. That point is touching or intersecting the x-axis. So therefore, that means that is the x-intercept. And we know what that point is going to be. That is 1, 2, 3, 4, 5, 6. It is the point 6, 0. Because again, if I go down, the x-intercept is the ordered pair that has some value x, and the y value is 0. It's always 0. And you see here, that's exactly what we have. The x value is a 6, and the y value is a 0. So that's pretty much it. That's all they ask us to do. We didn't even have to find the intercepts. That's just something that, was needed, or not even needed. A method that's easier to do in order to graph it. So whenever you have a linear equation and they're asking you to graph it, this is the most easiest way to do it. Have it set up in slope intercept form, so that way you can easily find either the x or y intercept, and then knowing the slope, use that to plot your other points to graph it. Easy as pie. All right, so next one will be this one. So we have this equation here to graph. X squared plus y squared equals 400. So this is kind of, what's the word I'm looking for? Interesting, I guess you can say, because I don't remember, learning about these types of equations earlier on in the chapter 1, but nonetheless, it is in this one. So that's good, because if you are, taking pre-calculus, you would see this, or maybe not. I don't really know how the instructors will go about doing this, but nonetheless, it is in chapter 1. So I guess for personal reasoning, you will want to go back and go through this particular section of the chapter. So if you notice how this is written, x squared plus y squared equals some number. So this is the form of a circle equation. This equation is a form of a circle, standard form of a circle. So the most general form of a circle I would give you is this here. So in parentheses, we have x minus h, that quantity squared, plus the quantity of y minus k squared, all equal to r squared. So the h and k, they represent the center of the circle, and the r represents the radius of your circle. So this is the most general form of a circle equation. And what we have for the problem, x squared plus y squared equals 400, this would tell us, or this equation here, we can pull information from it in order to graph it. So looking at the most general form of the equation versus the equation that's given, we notice one thing. We just have x squared plus y squared. There is no other numbers that will be inside of each of those being squared. It's just the x and the y. So that tells us the center of our circle is implied to be 0, 0 at the origin, at the point 0, 0. So we know that's where our center is. So based off of that, we can label our radius. So with that, from the general equation for our circle, we see the radius is r squared. So it's going to be some value squared. Now, if we look at our equation, the 400, this is whatever the radius is squared. So we need to find what number squared gives me the 400, or simply put, take the square root of 400. And when we take the square root of 400, we get 20. So the center for our problem is at the origin, the point 0, 0, and the r, or radius, is a length of 20 units. So we have all the information that we need to graph this. So now I'm gonna go over to my little graph template here. So I know my center is here. I'm going to put a dot just for, reasons. We don't have to. Just to know where my center is for the circle. Because if it wasn't centered at the origin, I would use it then to help see where that center is. But in this case, I don't have to, but I did it anyway. So now the radius. So we know the radius of the circle is the amount of distance or units away from the center of its circle. So in this case, we will be 20 units away from the center or origin of our graph. Now here, this doesn't cover 20 units. Let me see, in total, it's, if I count by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, by 11. So I'm going to do this by, let's see, I want to make it kind of a good size. So we'll do a units of 5. So 5, 10, 15, 20. Let's make it units of 4. We'll make it some more. So 1, 2, 3, 4, 5. This one. So here. So this will be the outer rim of my circle. So now I have that distance from the right side of the x-axis. So now I want that same distance all the way around because, again, this is a circle. We know how circles look. So again, 1, 2, 3, 4, 5. Over here, 1, 2, 3, 4, 5. And here, 2, 3, 4, 5. And then I'll just draw my circle as best as I can by connecting the dots. There's my circle, quote unquote. But yep, that's all that is to it for those circles. Again, if there were something else for the center besides 0, 0, you can look that up on how to do those, but more or less it's the same process when graphing it. Figure out what the center is, figure out what the radius is, and then apply it on your graph. So now, moving on. All right, so this one will be our last problem for the day, which will be fitting because this one has the most work to do. So graphing this equation in the XY coordinate system. So we see here, we have it in a standard form of a linear equation. That standard form is ax plus by equals c. That's our standard form. But I don't want it in that form because I can't really, by looking at it, I can't tell what I need in order to graph it in my XY coordinate system. So I will need it in another form, which is the slope intercept form. Again, that is y equals the mx plus b. I need it in this form. So in order to get it in this form, I need to solve this standard equation by the variable y. So that is exactly what I'm going to do. So I'm going to just rewrite it down here. 3x minus 4y equals 120. And I'm going to solve for the variable y. So the first thing I will need to do is to get rid of the term 3x, move it over to the right side of the equation. Minus 3x on both sides of the equation. I'm left with a negative 4y equals, and I'm going to put the 3x term out first. So that would be a negative 3x plus 120. And now to get the y by itself, I need to get rid of that negative 4 from it. And I do so by dividing both sides of the equation by negative 4. So on the right side, since we have two terms, that means I'm going to divide all of those terms by the negative 4. So that will leave me with y is equal to, you see I have a negative divided by a negative number, so that tells me it's going to be a positive. So positive 3/4 x. And I have a positive from the plus 120 divided by a negative number, so I know it's going to be negative already. So 120 divided by 4, that is 30. All right, so first objective completed. Got it in the slope intercept form. Y equals 3/4 x minus 30. So now in this form, I can tell what would be my slope, what would be a point that I would need in order to graph it. In this case, the y-intercept. Again, that is the point 0, negative 30 in this case. Because again, the general form for the y-intercept in that form is 0, comma b. And b in this case is the minus or negative 30. The x value for the y-intercept, again, is always 0. So easily we have one point that we're going to use in order to graph this equation, the y-intercept 0, comma negative 30. So now with this number, again, my graph doesn't go all the way to 30 on either side, just goes to 11. So we are going to use increments of, so this is going to be kind of tricky because of the slope. We'll get to that in a minute. So let's see, what units of measurement do I want to do this in? Let me see. Let's do units of, let us do units of, let's do units of 5. Let's do units of 5. So 0, 30, 0, negative 30. So 0, negative 30, I'm going to go down. 2, 3, 4, 5, 6. This is my y-intercept. So now my slope is a 3/4. So my rise is a positive 3 and my run is a positive 4. So that means from the point that I am at now, I would be moving up 3 units and to the right 4 units. Now, since I did this in units of 5, it's not going to look all that great. So somewhere, the next point will be somewhere, well, just for what's the word, no confusion, I'm going to use the lines. So up 3 1, 2, 3, and over 4, 1, 2, 3, 4. I know this isn't mathematically correct, but just for the sake of you guys understanding how to plot it, that's what we're doing this for. So another point, 1, 2, 3, 1, 2, 3, 4. And I'm going to stop there. If I go any further, it will be off the graph. So the line will look something like this. And if you have a graphing calculator, if you have a graphing calculator, you can, if you know how to use it, you can plug in the y-intercept form, the 3/4 x minus 30, and you'll be able to tell, you'll see that it looks similar to this, but you'll be able to get the exact points for the graph. So with that being said, that will be the end of this video. Again, I hope you guys enjoyed it. In the next video, we will be doing, let's see what we'll be doing. We will be performing indicated operations and writing our answer in the form of a plus bi, where a and b are real numbers. So this is going into your complex numbers, and the imaginary value I, which is equal to the square root of -1. So we'll be diving into that. So I hope you guys will be ready for the next lesson. So again, with that being said, that'll end this video. If you enjoyed it, you know what to do. Like, share, subscribe. Get this out there to all the nerds in the universe, multiverse, and alternate dimensions. And I will see you guys in the next one. The Immortal Nerd, signing off.